So my talk about today is about how we have really data in the JVM, and we want to work with pandas on the top of that. So it's a bit of crazy, more far-fetched than I normally do on Arrow talks, but as there was a bit of Arrow in the keynote, I thought I have to write something more crazy. And part of the first time of the talk was already working on Arrow data in pandas without doing a copy. I did that talk in Berlin. This now is one step even further, even more crazy. I have data in Arrow in Java, and I want to work with pandas on top of that, but not doing any copy. Sadly, this morning, my internal keyboard broke, so I'm also doing now with external keyboard a presentation, so I'm not sure if the code presentation at the end will work as smooth as I hoped. But beginning, I'm a data scientist at Blue Yonder. I work at my Blue Yonder time on Apache Arrow and Apache Parquet. We use that already productively. But in the end, I'm a pandas user, so everything I want to have at the end should be accessible in pandas, should work fast with pandas. So that's always my aim. A nice thing, we have some disadvantages in pandas, like it's fixed to Python. And that's a nice thing which happened in 2016. Apache Arrow was announced. The basic core of Apache Arrow is that it's an in-memory data layout. So it actually specifies how you should place data in memory, not on disk or so. You can put it on disk, but the main thing is keep it in memory. And by keeping a sane and specific specification in memory, you can pass it around between processes or over your host, and you don't have to reorder anything. All the participants who understand Arrow can work with the memory directly. It's a common memory layout, but so it needs to be catered for all other cases. So even though defining a memory layout sounds simple, you need to keep in mind how to deal with the SIMD instructions in your modern CPUs, how does the cache of the CPU work, and also a bit in mind, how does it not work on a GPU. And one of the really good things to see how well the project is running is there is support for 11 languages. The pull request for C# is open, or maybe even merged by now, so that we have really a long list of languages. Hopefully I didn't forget one here. But it makes it really as a universal framework which you can use everywhere. As a Python user, there are normally two typical use cases where you know Arrow. One thing which got me started is I wanted to read Parquet files in Python. And I wanted to read them really fast because I have huge amounts of data. So waiting for them is not really so nice. And also, the big public experience of Arrow, or where a lot of people will use it, is there is the Pandas UDF decorator in Spark. You can use that to make Spark UDF functions written in Python much faster. It's called Pandas UDF, but in the end what it does, it has a serializer internally that uses Apache Arrow to talk between Scala and Python. But you talk with it over network, so you're copying some data. And in the end, copying data is not what I really like, because copying data takes time, costs RAM usage, and that's all the things Apache Arrow in 2016 said, yeah, we're going to solve this. These are the two main pictures which were on the homepage in 2016. They're still on the homepage. They're still the goal of Arrow. So meaning you have a lot of data analytics products on top, and on the bottom you have a lot of different storages. You want to bring them together, and you don't want to write every pair of communication between them, custom serializers that are slow, that are complicated. But when they all commit to one memory structure, at least for interchange, you write once an Arrow adapter, and all other parties which also implement Arrow can deal with that data. And they can deal with that data really fast. Because the serializer, you write one serializer or one conversion, or you already use Arrow internally, and you can concentrate on that. In 2016, this was only a goal. But we're actually at a point now where, depending on which two pairs you pick, it really works. Looking about how you do machine learning, or how do you data science at the moment. A typical workflow for me at work is you have an SQL engine, maybe backed by a normal relational data store, maybe it's backed by some Parquet files, or maybe by even something else, but you have an SQL engine. That you use that to join your data to get a big table view, flat view that you can put it into pandas. Use some pandas for data preprocessing, shuffle around some columns, fill some missing values, and then push it into your machine learning model. The last two tasks, they happen both in Python, and they're really efficient. But there's always a kind of disconnect, because this workflow here looks simple, but in the end, this isn't simple workflow. In the picture, just 3 components, simple working together, but between the SQL engine and Pandas, there's normally a big delay. The engine is fast, Pandas is fast, but the layer between isn't fast. That's mainly due to that everything in these data landscapes, with data analytics, data science, and so on, is really heterogeneous. There are these big Hadoop setups with Java products that work really well, that scale okay, but they're in the Java world. And in machine learning, we typically use Python, which is a different whole ecosystem, other data structures, and so on. So when we look again at the workflow we had just, there's a whole gap in between. We have the SQL engine, which then returns data through a driver. If it's in Java, in my case here now, where I'm looking at, it's a JDBC driver. So there's often databases bringing ODBC drivers, but they're normally just, here you have your ODBC driver. It's just enough that you can use Tableau on it, because Tableau or something else needs ODBC, but we actually don't care. Use JDBC because you typically also have a Java service. And also, often, you have these big engines. At the end, you normally get a single line result because you're doing aggregation over 1 million or 1 billion rows. And in the end, you're interested in your report to put like the whole profit of the year. That's it. But for making data science, we normally want all data. We want a big flat view, and it's a huge amount of data. That's normally what drivers are not optimized for. And in Python, you can use JDBC drivers. There's a thing called JDB API, which starts a JVM in the background, loads the JDBC driver, and then takes the JDBC rows, which are returned by the JDBC driver, and converts them to Python rows. Sadly, Python rows is not the data structure we're using in Python or in Pandas. In Pandas, we want columns of data, especially columns of NumPy data. And we all know that Python rows are really, really slow. And when we just make this conversion, we have to wait a long time. In contrast, if you do that conversion in Java, we have at least a just-in-time compiler. That's not a thing we have in Python or Pandas. And also, we're copying the data here several times. We have it as a row form in Java. We copy it over into Python. This is the most expensive part because we copy it and we have to cross the language border, which costs us a lot of CPU power. And then once we copy it again, when we pass it to Pandas. Now, the nice thing in the Arrow project is, I talked about that we have 11 languages support. It started all out with having the C++ and Python implementation, and on the other side, the Java implementation. I think at current state, they're still the both with the best support. And we're normally looking at Python conference at the Python and C++ side, but actually, as we have data in Java returned by a JDBC driver, we can use a tiny bit of Java. And the good thing is in Arrow, we have since 2 or 3 months a JDBC adapter, which gives you anything which a JDBC query returns, then as an Arrow record batch, or in Java it's called a vector schema root, which is basically the same thing as a Pandas DataFrame, a collection of named columns. Record batch in Arrow is the most simple structure. It just contains continuous arrays. There's no chunking or slicing happening. We can do the row to column conversion in the JVM. That's sadly a thing we always have to do because JDBC only has a row-wise interface. So maybe a better thing in future would be to have an alternative to JDBC that already gives you columns. The other nice thing is Arrow uses off-heap memory, which is not always the best thing in Java, because Java developers are a bit scary about off-heap memory, but you can use it, and Arrow gives you nice interfaces to it. The other good thing about it, it's the same memory layout as you would use in Python, meaning that the data is already in memory how you would use it. You could pass it to any other process, which gives us then an updated workflow where we have a JDBC driver, we have this Arrow adapter, and we have an Arrow table. The bad thing is we have an Arrow table or a record batch in Python, in Java. but we're still not in Python. We can't access that memory. And also, we have arrow, and at the end, we want pandas. And these two are still components that are not working fluent with together. Already mentioned at the beginning, there's PySpark. PySpark has a conversion layer that you can write some data in Spark and then pass it over the language border to Python. This is already giving you a good speed up, like sometimes 2 times, sometimes 10x. The disadvantage is still it copies data over network, meaning you have at least one data copy. And network is normally not so fast as if you just take the memory as is. And also, the arrow to pandas conversion, it's really fast. So there's a lot of magic happening in there, and that's the good thing we have Wes in the project, because he also knows the pandas internals. So that we directly fill the pandas data structure as pandas uses it internally. We're not giving in a dictionary of NumPy arrays, but we're actually giving the data structure pandas is using internally. Coming up to that later. Now, to look at the data where we have an arrow record batch in Java, and we want to use it in Python. The nice thing is the layout is the same. So actually, I have to just get access to that data where it's in there. And we have a new module in pyarrow which just does exactly that. It takes the Java objects through this same code that we're using in the JDBC API, which is dtype, which gives you access to a JVM running in the same process. But instead of copying the data over, it just accesses the Python arrow, the Java arrow object, and makes the new metadata in Python out of it. And it's just the metadata. It's not taking the actual payload data. And the metadata is just typically in the range of some bytes or 1 or 2 kilobytes. And you can have 10 gigabytes of data. And no copy of the actual data will be happening. And we pass these references around. We also have to be careful, but the module is done, that we take care of reference counting. Because we're now having Python objects that reference Java objects that reference our memory from arrow allocated in Java. And that brings us now to the point where we can actually access the data in Python and haven't done a copy behind that. So the next step is we should bring it into pandas. But sadly, pandas is not the same thing which we actually want to have. An arrow table is a collection of arrays with a column name, and inside an arrow array or a column, there's one array, but this one array is at least 2 memory regions. It's a valid bitmap saying you if there is a null value in your actual row or if it's not, and then the actual data. Pandas in itself, it's made up out of NumPy. NumPy has not really it has some support for missing values coming through mask arrays, but mask arrays are more second-class citizen in NumPy. And pandas itself is not using these mask arrays. It's just using standard NumPy arrays. And that's a typical case when you have an integer column, you assign none to it, and it turns into a float column. So the same thing is when we have an integer column in arrow, you assign, it has a none value in it, and when we want to convert it to pandas, it will turn into a float column. So we have to copy this column. The other thing is there's a pandas internal thing called the BlockManager. The BlockManager allocates all data that is from the same type into a big pandas matrix or NumPy matrix, meaning that if you have 20 float columns, it will be a 20 size number of rows matrix in your pandas data frame, and there you store your data. And in arrow, you normally just take columns. So when we have more than a single column per type, we have to copy. Yeah. So we have the data types which don't match. Also, because there is no string type or there is no decimal type in pandas. In these cases where you have those, you have to copy. I already mentioned the BlockManager, pandas groups by types. So that's also a thing why we can't just copy into pandas from arrow, because in arrow columns are separate and the nullability is a problem. So at the end, there are at least 3 points, maybe even more. That means arrow memory and pandas memory are not the same. So you have to have a copy, and copies are bad. The cool thing is if you have like 5 gigabytes of data, if you have it on your laptop has 16 gigabytes of RAM, you still can work with it. But if you do 2 or 3 copies at the same time, your laptop is too small. A nice good feature in Pandas, which is available in the latest release, but actually you should wait to the next major release of Pandas, are extension arrays. Extension arrays are a small set of interfaces you need to implement, but they're really powerful. The powerful thing about them is you implement storage for a Pandas column, but the analytic on top is provided by Pandas and not by you. You can override some of those analytics, but the magic happens all inside of Pandas, built on top of you. And in 0.24, there will be much more features building up on that, like the categorical columns in Pandas or the timestamp columns. There will also be extension arrays. And the really nice thing, people are looking forward, there's also an integer extension array built into Pandas in 0.24, which gives you nullable ints built into Pandas. But this kind of concept is something we actually could also use, because we have already arrow data, which is stored in memory, which has the same properties. So I created a library which is a bit of more prototype, not production ready. It's also a library which needs kind of a lot of master branches or pull requests. It's called Fletcher. It implements the Apache Arrow interface. It uses Apache Arrow as backend storage, but it implements the extension array interface. And to keep it pure Python, I used Number on top of that to have the missing algorithms implemented. So there are still 2 or 3 things you need to implement, which were not I get in Arrow. And just to give a small prototyping in Fletcher, I use Number on top of that. You can pip install that, but I would suggest always to use the master branch if you want to try it. And also, the best things also if you use Arrow master, Pandas master with that. But that's also maybe a future thing which could be built into Pandas, just using Arrow as a backend storage, so that you don't have to always copy your data. And the benefit of using that is now, when I pass all my arrays I have already in my record batch coming from Java, I can make a Pandas data frame out of the record batch simply by allocating these extension arrays. And at the end, I have the thing, I have data which comes with my SQL engine. The JDBC driver talks to my engine, gets the data, sadly still converts to JDBC rows. But then I have an arrow converter which converts the rows as my own single copy to arrow. The arrow memory is allocated in Java, referenced in Java, but is passed in over the language boundary just by the metadata and the memory addresses. And then referenced also by Python. And in the first case, just by pyarrow, but by using also Fletcher, I can turn my arrow columns into Pandas columns, and I can actually work directly with Pandas on this data and pass it then into my machine learning model, meaning I have just a single copy between JDBC rows and arrow data. And this one copy is sadly unavoidable, but it's at least not on language border. It's still on my JDBC, on my Java side. So if you have building Java databases, which probably not so many people in here will do, just think of just returning columns instead of rows. It's really good for analytics. And also, a lot of these things I'm telling you here is a lot of big pictures. So the question is he actually telling you something that's working, or is he just giving you big pictures? I'm not going to show you how the code works for the non-arrow side. It's quite simple. It's at the top. It's importing JDB API. It's connecting to the database, giving you the driver. I used in this case for benchmarking Apache Drill, which runs really good in a local mode. And I just use one big Parquet file just to have the machine learning expertise. I have this one table, which is really big, and I just want to fetch it. And JDB API is implementing DBAP2, so I can just pass and read SQL and Pandas. The main problem why I'm not showing it takes 11 minutes on my laptop. It's an awful lot of time just for loading data. And that's already on my laptop. If you would pass this over a network, it will take even longer. And we can now also have a look at how this will work when we're not using JDB API, but when we're using the code I mentioned here. I'm I have to do a lot of imports. And I'm using here a small snippet called IPython memory usage, which shows me the memory usage of my current process and how my current cell affected that. So that you actually see what's happening inside here. So I had already my JVM running, my Python running, and also my JVM running. That's why you see a large decrease in memory. But here, with the next row, we're clear with memory. And we have a current usage, which is quite high because we have a warm JVM, and a warm JVM in the background takes a lot of memory. But the thing is now we want to get at the point that we see that we don't take any more memory. So we can load a driver, allocate a root allocator in Arrow. That's basically an allocator for Arrow tables saying you don't allocate any more than this amount of memory. As we're not building a database system here, I don't care about that, and increase to the maximum size. Connect to my local database, and use the same query I showed on the slides again, which just selects a huge amount of data and execute that directly with dtype. So this code here is connecting to the JVM, which is running in the same process but another thread, and calls the SQL to Arrow adapter, which takes a query and takes a root allocator, so it can allocate Arrow data and pulls all data from the database into here an Arrow JVM memory. At the end, we can see it takes 293 megabytes. So there's already some data in here. The next thing is I have that data in memory, but now I want to have it in Pandas. Or actually, I first want to have it in Python. I can then call this JVM record batch, which takes a JVM record batch and turns it into a Python record batch in Arrow. Small bit of metadata added, 0.4 megabytes. It's okay. It's a bit more than I would have expected, but it's a lot less than my 300 megabytes above. And now I'm using Fletcher, which is shortened with FR here, to convert my Arrow record batch to a Pandas data frame. And that also gives me a bit of increase because I have now a Pandas data frame object, but it's 0.2 megabytes, not 300 as above. And to show you that it actually works, we can have a look at the data in Pandas. And can see here we have some data in there. Pandas can plot it. And we also can call df.info and see that we have typical Pandas data frame output here at the top, but also we have this kind of magic Fletcher columns, which are the same types you used from NumPy also, but they are Fletcher columns because in the end, this is not a NumPy type at the end, this is an Arrow type. And you can work with this data here. And yeah, that basically shows how you can use JVM data in Pandas. I hope that was convincing now that it actually works, and it's not just some fake I put on my slides. Yeah. And if you're interested in these things, I work at Yonder. I have fun with that. Join me, or the other important thing is Apache Arrow is an open source project. There's a lot of things going on, and there's a lot of things where you actually get this kind of 10x, or in my case, it was at least more than 10x, in performance improvement. It takes some time to look into the project, but actually it's right satisfying at the end because you get a huge amount of speedups, and you also get a huge amount of possibilities because you can now connect systems which were totally separate before. Yeah.
So thank you for that great talk. Any questions?
So thanks for a great talk. Very interesting. I was wondering about that Fletcher project. Are you one of the maintainers, or is it just something you discovered? And if you are actively maintaining it, what is kind of the vision for it? So is this something that will go away once Pandas and Arrow are better integrated, or is it something that will remain in your point of view?
I'm one of the maintainers. So the other maintainer is Florian, who's also at a conference here and giving a talk tomorrow. And also Christopher is one of the persons who started, also at a conference, will also give a talk tomorrow. So all three maintainers are here at the talk. or not at a talk, but at a conference. The thing is, it's a prototype at the moment. It's not something you can use in production. It's more kind of testing a vision, because there's a lot of documents from Wes McKinney where you can look up what's his vision for Pandas 2.0. And one of those things is build Pandas on top of Arrow, which is a lot of breaking things because you're not using any more NumPy. But Fletcher is a good thing to test. Can you work on top of Arrow? There's a lot of things still missing, and it's not really working perfectly, or in some cases it's really slow. But there's a lot of cases like when you can already take Arrow string columns, and that's a thing where you already get a 2 to 4 times improvement. But yeah, maybe one day it will be also part of Pandas.
Any more questions? Otherwise, I have one. We just heard a talk about PyTorch. Do you know if there's any efforts to also connect like deep learning frameworks to Arrow?
Uber has released 2 weeks ago a library called Petastorm, which connects Arrow and Parquet to PyTorch and TensorFlow. They're embedding videos and images into Parquet files or Arrow files, and then use pyarrow to load the data into Torch or TensorFlow.
Cool. Thank you very much again.